Welcome to Digital Ship webinar on 5G in maritime challenges and opportunities. Which new possibilities will 5G open in the maritime sector, and what is the difference to 4G LTE? These are just some questions that you will learn very soon from our guest speakers. Let me introduce them to you. Frank Wötzel, CTO of Sputnik24, Holger Ritter, Managing Director of DRYNET, and Dennis Becker, Head of IT at a ferry operator company based in Germany, FRS Europe. As always, we are jumping straight into the conversation with Carl. Let's get started.
Okay, thank you, Vida. So what we want to do today is learn a lot more about what 5G can do for the maritime industry. There's a lot of hype about it, and we want to understand what we can really do. So you probably already know the basics. We've got a higher speeds and lower latency and greater data capacity, but it's not just like a product which you can buy or not buy. People see it as a sort of platform for the future. So there's talk about integrating 5G with 4G and integrating 5G with satellite communications. Now, there's two separate communications links we're talking about here. We're talking about the data communications on board the ship itself, for example, for sensors from containers all talking to a central terminal. And then we're talking about communications from the ship to the shore. Now, for ship-shore communications, you might choose to use a 4G, which has a further distance to go from the shore, or you might choose to use 5G. 5G has a shorter distance it can go, but the 5G can work together with a 4G network. And with a Sputnik's technology, you can go 5 nautical miles. So we've got 3 talks today. So first of all, we're going to have an introduction to 5G, and then we're going to add some technical depth in the second talk. And the third talk, we're going to talk about a case study of cellular communications on a ferry. So the talk's going to be 10 minutes each, so we'll have lots of time for questions. So if you load your questions up in the Q&A box, you'll see at the bottom, and also vote for the questions you'd like to see answered. Then we'll have 20 minutes or so to go through those. First of all, we've got Holger Ritter, who's the Managing Director at DRYNET GmbH, which is a communication solutions and consulting services company serving oil and gas, offshore and maritime. And they're also sponsoring the webinar today. And Holger's worked in technology consultancy and sales for 32 years, including as EMEA Director of Sales for Connection by Boeing and General Manager EMEA for Commercial Shipping and Energy at MTN Satellite Communications. Then we've got Frank Wötzel, who's the CTO of Sputnik24 Communication Systems GmbH. So that's specializing in antenna and communication network design. And they developed a patented Sputnik24, which is combined maritime 4G LTE high-speed internet access system, which gives cellular shore, you can communicate to cellular shore networks, which are up to 50 nautical miles away for more technical depth. And finally, Dennis Becker, who's the head of IT for vessel operations with FRS, which is a ferry operator, will give a case study on cellular communications on his ships. So he's been working on ferries IT for 15 years, and they have 60 plus vessels in their fleet, including 676 passenger high-speed craft going between Germany and Sweden, and it's connected with the Sputnik24 antennas. So I'd like to invite Holger Ritter to give the opening talk. Thank you.
Good morning, ladies and gentlemen. Thank you very much, Vida and Carl, for the introduction. Please let me try to share my screen now. So I hope you can see all my presentation, and I will talk about the challenges and opportunities regarding the 5G. Yeah, thanks a lot for joining our webinar today. My name is Holger Ritter. I'm founder and managing partner of DRYNET. And let's talk a little bit about the 5G vision at first. I mean, you will all experience currently cellular operators in many countries roll out 5G networks. The Vodafones and T-Mobiles of the world want to impress us with the new network capabilities. They are investing millions in marketing campaigns and generate a kind of hype to convince us all to migrate to 5G in the next months and years. 5G promises a fantastic value, such as 100 times more devices per cell connected with IP version 6, speeds up to 20 gigabit per second, and most important, packet round trip times of 1 millisecond. Yes, I think this will for sure enable a lot of new application opportunities. However, we are still in a very early stage and standards are still in development, and supply of devices is very limited to a few manufacturers with currently Huawei in the lead. So let's see how this all relates to our business. Despite the hype, the Internet of Things, IoT in short, has yet to deliver its promised benefits to industrial companies and especially to maritime. But with the advent of 5G, this removes many of the technical barriers to IoT successful adoption, accelerating digitalization also on ships. Let's see what other digital and telecommunication industry supplier Ericsson estimate the value of 5G-enabled IoT to be in 2013, about $1.5 trillion US. And the graph we see here shows the share of service creation opportunities for cellular operators until 2030 across the industry. However, maritime and shipping is not explicitly mentioned here. So I thought the question is, how will or even can shipping benefit from 5G? So the points I want to talk about, a few words about DRYNET, then I will give you some information about a nearshore connectivity survey, and then I will talk about ship-to-shore communications first and Internet of Things next. Let's start. DRYNET features around a dozen industry experts who combine in-depth communication and maritime knowledge with the long-term experience of projects in all maritime sectors. We are supporting our clients, especially with the integration of hybrid communication systems, combining satellite, cellular, and terrestrial technologies. But since 2019, we have helped more than 30 shipping companies with hundreds of vessels to leverage cellular LTE networks for their ship-to-shore communications. Additionally, we are working with industry partners in several highly innovative IoT projects. The digital transformation is shaping companies across the world, and ship operators are part of that movement. Shipping needs a broadband communication infrastructure for Industry 4.0 or for IoT. And despite the significant advances in satellite network, terrestrial cellular networks already offer today huge advantages in cost, performance, and latency. A recent done survey by Vodafone called Near Connectivity Survey found out that on average ships spend about 60% of their time in port or coastal waters. That means potentially within 4G LTE coverage. And 4G LTE is available today in 93% of all coastal countries. This almost universal coverage of 4G LTE networks means that ship operators could potentially connect all vessels at port and close to shore at significant lower cost and higher speed in comparison to satellite. Therefore, we think that despite of 4G or 5G discussions, only a hybrid communication infrastructure which combines terrestrial, cellular, and satellite will enable vessels to really benefit from those new applications. Let's take a look at the requirements for ship-to-shore communications and how existing 4G and upcoming 5G networks correspond to it. This comparison clearly shows that 4G LTE currently provides the robust and cost-efficient state-of-the-art infrastructure for ship-to-shore technology. As 5G includes the fallback to LTE when it comes to long-range connectivity, something that Frank will, in the next presentation, explain a little bit deeper, we expect that LTE remains the dominant ship-to-shore technology over the next years. And what is also very interesting is that recently satellite operators like Inmarsat, but also low Earth orbit constellations, announced that they are planning to bridge the gap between onboard and onshore 5G networks. However, it is highly unlikely that all 5G promises and benefits, for example, the 1 millisecond latency or throughput over 1 gigabit, can be kept this way with a satellite bridge between ship to shore. Let's look a little bit at the Internet of Things part on the short-range communications. IoT, or Internet of Things, this is what 5G is really made for. High throughput, low latency communications over short distances. Most deployments of 5G networks onshore focus today on such campus networks. Private 5G networks based for a campus like an industry factory or a university or similar. Or for example, in ports, where it can enable autonomous vehicles, robotics, or mass sensor data collection. But therefore, maritime 5G use cases can be, for example, also gathering of data of thousands of sensors, tracking variables of crew and passengers, as well as semi or full autonomous operations, including drones and robots, if you think of the future. However, the onboard 5G infrastructure is competing against lower cost Wi-Fi. And 5G onboard needs an uplink to the core 5G network onshore, which can be done over LTE or over satellite. But as long there is no 5G roaming between different countries implemented, it will be difficult for vessels sailing around the globe to use their 5G infrastructure anywhere. And that's more or less also the approach that Inmarsat is going to bridge that gap. The ship-to-shore connection, therefore, will still be mainly provided by LTE. My last slide summarizes the situation. LTE 4G remains the state-of-the-art ship-to-shore technology for the foreseeable time. As in the IoT sector, with 5G offers a growing opportunity for onboard and short-range communications. And we are all very curious how this develops in the future, especially with the integration on satellite platforms. This is my short introduction, and I hand over to Carl again.
Well, thank you very much, Holger. So now I'd like to invite Frank Wötzel, who's the CTO of Sputnik24 Communication Systems, which designs antennas and communication networks. So we're going to get into more technical depth about how we use 5G on ships. So I'd like to welcome Frank. Thank you.
Thank you very much for the introduction, Ryder and Carl. And hello and welcome again to ladies and gentlemen joining that webinar. I'd like to start with my presentation. I hope it will work. So my name is Frank Wötzel. I'm the Chief Technical Officer of Sputnik24 Communication Systems GmbH. And I prepared for you today 5 topics, starting a little bit explaining about our company, what we are doing, and ending with an illustrative part about cell size, maritime coverage, and 5G use case scenarios. And I thank you also, Holger, for the good preparation of everything. And please allow me to start to talk about our company. So we are located in Leipzig, Germany, and we are specialized on developing and manufacturing maritime mobile antennas for well-known cellular network services, as well as for special frequency ranges. So our lines of business are, beside R&D, of course, the design of communication products, and with a special field of the antenna design, and we offer for that as well consulting services. Manufacturing is done here in Leipzig on the company itself. And additional to that, we also are doing software for communication products and especially software for quality assurance and monitoring for terminals on the sea. Our special product, which already Holger introduced today, is called a long-range LTE antenna, which you see on the right side. And this product is designed and manufactured here in Germany, in Leipzig, and it gives you the advantage that we can reach up to 50 nautical miles if all the conditions are met. And the system consists of two parts. You see an radome, which is the outer unit, and you see a metal box, which is the below deck unit, which gives you the kind of internet router. This antenna is especially designed for maritime purposes. So that means we included specific and special antenna functions for the LTE service, as well as we included the pattern of the antenna, the demands of the maritime network. So, and with help of that, it is possible to reach the cell tower even in very far distances on sea. Of course, there is some new technology included, and we are happy that we got the patents for this product granted in many countries, including European Community and United States. So, and related on that, I like to show you within the next slides the development of the network and cellular services, as well as what it means for maritime access to 5G. This is a short slide about how things have developed from 90s up to today. And on the left side, maybe this is a very well-known product, starting with the voice communication first, and later we got less than 200 kilobit per second, and now we are talking about a few gigabit. So meaning in the last years, this technology really got an acceleration in the development, a real evolution of connectivity. So a little bit more theory. Let's talk about where we are today and what is thinkable for the next decades in 5G. There is, of course, a standardization of this process, and this is a slide from Vodafone Deutschland, which shows what are the agreements and what happened. In 2019, an example, the arrangement was to get more spectrum. In the release 16, we even talk about more spectrum again, which is costly and which is not endless resource. And now we talk about the support of millimeter wave bands. And with the release 17, we go even higher in the frequency range. So this all has impact to the type of service, to the usage scenario, and of course, to the distance to the cell tower. And this is maybe a good overview also from Vodafone Deutschland, how things are designed in a way to say what is 5G today. We're starting with the most interesting thing in terms of speed. This is the so-called small cell, which gives you 1 gigabit per second, but in a distance of 1 kilometer from the cell tower. That's called the high band. The mid-band, which is also known as 1.8 gigahertz range, it gives 2 to 3 kilometer distance and up to 500 megabit speed. And the so-called long range in 5G is a 200 megabit cell, which gives up to 5 to 8 kilometer connectivity. But this again needs to be reviewed under the circumstances of a maritime scenario. And so to having better impression how things are designed, let me introduce you a small sketch about the relation of 4G and 5G. On the right side is the explanation. You see the very small cells are the 5G high-speed cells, 1 gigabit. The green one is the medium size with 500 megabit, and the gray one is 200 megabit. And the blue one, of course, is an example for the 4G LTE cells. So these cells, LTE and 5G, are and will be overlapping, so that the 4G can do you a fallback from 5G services. What is also clearly to see, there is a coordination issue, so that we call about multi-color model, that 5G cells are not disturbing each other. But on the other hand, also there will be a concentration of 5G cells, especially the small cell, where the requirements, that means the customer, are. In such a case, we talk about what Holger already mentioned, in example, machine-to-machine communication. And it's just to giving an impression what is the size and what is the advantage and disadvantage. And clearly we talk about nearshore and offshore communication, and then 4G and 5G will develop to a special relation to each other. And having here a more better example, but this is just again a design example. If we see the port of Rostock, which is port to the Baltic Sea and north of Germany, then we can think about to make a design like this. This is the related 5G cell size and giving 1 gigabit per second to every cell. And it is already here to see that there are many cells required just to fit the port, but on the other hand, then in such a region, the whole territory is nicely covered from entering to the port till parking positions on the port with very high bandwidth. So there are different use cases and scenarios thinkable. And this would be the related 4G cell to it. So just to having a comparison about. Now let's do it a little bit more in a larger scale, the same port, Rostock. And here are the 5G cells. If somebody is not seeing them, they are here on the bottom of the red arrow. And now let's see how things are today with the 4G operator. This is just an example of a local operator in Germany, which goes far also into the international waters. And on the other hand, we might have a 4G LTE operator in Denmark. And you see here very nice overlapping between two countries, two different operators which live in coexistence in the neighborhood. And this enables to possible users, maritime users, a very good coverage if the system is supporting that. And meaning supporting that is that there are design criteria which have to be met to reach that. So, and these are much more, if you see it at a global scale, options to give to the ship owners really a good coverage if they are nearby the shore. And really near the shore, 5G will be a nice thing. But to combine both, this might be the challenge for the future. And you see the difference from macro cell in 4G to the macro cell in 5G. And that's what I want to talk about is the machine remote control, which might be one of the first applications of 5G use case scenario, where we say you have a port, you have container ships, you have automatic machines going over there, and really short-term communication is required with low latency, high availability, and high throughput. And this might be one of the very new and very exciting technologies for the future. But again, having this on a ship as a 5G cell as well means coordination. And the coordination, as Holger already said, is not yet done fully. And this will be also from the theoretical part and from the legal part, a challenge for the future. Thank you very much for your attendance, and I give back to Carl.
Well, okay. Thank you very much, Frank. And I'd like to draw the audience's attention to the Q&A box at the bottom here. So there's some good questions come up already. Looks like people are interested in how 5G fits into the web of communications options available, which is pretty difficult, but we'll get into that afterwards. Or Frank, you're also able to reply by text if you'd like to, or you can reply orally afterwards. But now we'd like to hear about the practical experience. So I'd like to welcome Dennis Becker, who's the head of IT with the ferry operator FRS. So they've got ships going up to 676 passengers, high-speed craft going between Germany and Sweden using the Sputnik24 antennas. So I'd like to welcome Dennis. Thank you.
Yeah, hello. Good morning also from my side. I'll just share my screen. Yeah, I'm Dennis Becker, head of IT operation vessels for the FRS group based in Germany. I just want to give you a brief overview about our company, then how we went into the mobile communication on board our vessels, and a case study about our new route between Germany and Sweden. We have around 150 years of experience in the shipping business, starting from a small local carrier for duty-free travelers between Germany and Denmark. So today, an international group with about 60 vessels and over 2,000 employees around the globe. Our main fields are passengers and vehicle transport, as well as the offshore logistics, crewing, and management services. We came into 3G and 4G project around 2006 as the management decided to open up more routes and especially not more dedicated ports by a fixed vessel. So as we was using Wi-Fi connection before, we was always limited to each side one Wi-Fi connection, and then we had the advantages of not more owning buildings or high infrastructure in each port. So we had to dedicate more on the vessel directly, so that each vessel gets an individual connection and would be able to run individual around the globe. So wherever we could shift a vessel, we would be able to go with mobile connection. In 2015, we expanded that connections with the Sputnik24 antennas in order to increase the time that we had for the 4G, 3G internet connection. Today we have around 30 vessels equipped with the long range, and mainly the advantage is the range that we take. We don't have any more shoreside installation. We depend really only on the installation on board, and all the alternatives would be the satellite with a far higher cost, and of course, especially on the smaller vessels, we would not even have the space for like 100 centimeter dome, as the Sputniks are far smaller in that range. We use that on smaller vessels, as I said, 40, 50 meters, up to over 100 meters. So it just depends on the use case. We have from the normal powered vessel till the solar, all in the fleet. Our main cases are the services that we offer on board for the centralized management. We have a lot of infrastructure just based in Germany, but sourcing all the vessels around the globe. And nowadays, the inspection department and financial, all they require to have reports right after the action was taken or the sales was taken. So we connect every vessel directly to our headquarters. Of course, as well as the PAX, the passengers, they want to have the Wi-Fi, they want to have their newspapers wherever they go. So we really depend on that internet connection for our own purposes as well as for the marketing and passengers. It is a constant growing in our traffic that we have around 200 gigabytes per month per vessel at the moment. But we have also kings like special lines where they can take about 1 terabyte of data communications per month as well. And we see that every new project, every new build we do is a constant new requirement for more and more cabling, more and more connections. For example, we did a new build in 2008 where we was just having 2 network connections on board of the vessels, and we did a new build in 2018, and we ended up with having more than 100 connections, which shows a bit how the system on board is changing in all different departments and all different areas. We just recently opened a new line between Germany, Sassnitz, which is on the coast of Rügen in Germany, and on the other side, in the south of Sweden, Ystad, a connection of around just about 100 kilometers or 58 nautical miles. We run there a 91-meter catamaran, which does an average of around 29 knots and can do a high speed till 44 knots with 636 packs and of 200 cars. Here we have the example of talking about the satellite or an mobile connection issue. We can see on the overlay, we started in the process of looking, are we able to cover that with mobile communication to avoid the satellite here? And the same as Frank was already mentioning, due to the different providers in each country, we are able to run from Sassnitz till Sweden, depending a bit on the route, fully with 4G connection, as we're using 2 of the Sputnik24 antennas. Either we have a straight connection going Germany, Swedish provider, which shows the blue and the yellow polygon, or depending on weather conditions or whatever circumstances, we take a more east or more west way. Then we end up shifting from the German to the Danish and then to the Swedish provider. That's a small diagram about the availability during a 5 days crossing. We end up with having an availability over 99%, which gives us in the reach of till 150 megabyte of a download and 50 megabyte of upload performance, which is really, really good. And we don't see there any need of adding an additional satellite. As with the long range, we're really able to manage it on a far lower cost range with mobile connection and LTE. What we expect for the future is, of course, an increasing demand of internet communication. Whatever it takes, it will have internet. If it's the maintenance system, if it's the people on board, if it's the webinar the crew takes to get the license, everything depends on internet in all our departments. We are getting more and more requirements by law to exchange the data right after. If it's an accident, if it's just leaving port, sending some documents, we have to be able to send it right away. With the change or the increasing 5G, we expect to have more bandwidth in the port area so that we are able to transport more data, more backups, for example, everything that is of a higher size that we will take today, maybe even offline, we will be able to transfer with 5G. We see the focus on 5G more on the shore side, and we still think that for the at least starting period of the next years, we are fully depending on the LTE with 4G on the long range. Our goal is to have the range out of the coast plus the bandwidth in the ports via 5G to end up to have improving that connection. Thanks a lot. That's from my side so far.
Oh, thank you very much. Yeah, well, it's fascinating. We've got a picture emerging about how this 5G all fits into the maritime sector. I guess there's two ways to look at it. One is to say you've got this really vast pipe, and the other way is to say this is a whole platform of the future where everything's going to get faster and faster and you can connect lots of things to it. So I think that probably the direction of the discussion is helping the audience understand better how better this picture of what how this stuff fits together. So if anybody wants to open up the Q&A box, so we've had lots of technical questions already been answered, but maybe we'll go into more of those. You'll see those on the answered screen, but on the open questions. So there's two specifically for Dennis. How do you bundle the ship to shore mobile data, and do you think shipping companies are going to want to use this to track containers? You're not in containers, but I don't know if you'd like to have a go at those two to start off with. Dennis, would you like?
Well, we track, for example, our engines. We are tracking the fuel. That's all what we track already today, or what we are starting also with new build projects, which is all live information. As the inspection, the superintendents, they want to have this information of all the vessels around the globe right, on one screen with IoT.
One thing. Go on.
Yeah, I mean, it could be an interesting opportunity to track reefer containers, for example, with kind of LoRa networks. And when they are integrated with 5G, that means the end user or the end devices you have on these containers consume very little power. So they could survive 3 to 5 years without additional power. And they can be tracked on shore, fully intermodal when they are on a truck or on a train. And when they go on a ship, they can still be tracked. If we have a kind of 5G cell or a 5 or maybe just LoRa or LTE local equipment on board a ship that could get the signal from them.
Well, if we're sure this is what the future is going to be with 4G and then 5G everywhere, then perhaps this makes sense to think about, doesn't it? Yeah. Now, one thing I was sort of personally confused about, so any communications link is only as good as the slowest piece of it. So there's no point in gathering enormous megabits per second on the ship if you're sending it to shore on LEOs that can only take 15 kilobits a second or something. Is that nobody kind of talked about this, but I guess this is something you're obviously putting into your thinking, but you're just assuming that everything's going to get faster over time. Is that right?
That's what we see during the last years. The providers are improving the shore side antennas and so on, so that we get more bandwidth, already changing 3G to 4G. Of course, but an antenna can really only take that what is there. Yes, and we have seen that in many cases. If we go in areas where there's no coverage, of course, then we still end up with this problem. And we had also cases sailing in the Bahamas where they just turned off the mobile connection for a day, and the vessel went offline as well. Yes, that we can't do anything against.
Oh, this first question from Frederick Hofgren about bundling ship-to-shore mobile data. I don't know if the data needs to be bundled. Is that one for you, Frank? It sounds a bit technical, is it? The question at the top of the list.
This is maybe a better question for Dennis, but from the technical perspective, there are challenges in bundling systems. And I think Dennis did a good job on the bundling two antennas with two providers to making things more easy for handover. But better to ask this question or answer this question from Dennis.
Dennis?
Yeah, really. We played a lot with that. We used different brands and different load balancing systems, different providers, and we sometimes we see that you can do it with an easy load balancing. It doesn't matter which brand, but it really depends also on the coverage. There are sometimes if you have two really low, you would not increase that much. But we are running quite well with a sonic wall setup, and we are really happy about and changing in many cases with two different providers, which works pretty well.
Wow. And then these two questions here. So both asking about is this like microwaves where you have two dishes pointing to each other, or? David Clutterbuck's already answered one of them, saying it's omnidirectional, but is there something you'd like to say anything more about, Frank?
Yeah, this is an important question, and also it is the matter how things are connected. So we have a scenario on the sea as well as on land, what you can license and what is falling under, in example, a GSM license like a mobile phone. And so our system is designed in omnidirectional way. Why? First of all, it is related to the use case scenario and to the standard, where we say the system shall be omnidirectional. And for that, it is not required to know where the cell tower is. And we are hardware manufacturers, so we are not involved with a cell operator. And in such a case, you don't have this information. So in the 4G network is self-organized, meaning the network is also deciding, the core network, about the terminals to which tower they can be shifted. So the modem and the network is aware where the modem, that means the terminal, is, and give the best connection. Simple example, if the modem is just there waiting, then it will be connected to a tower where other terminals and mobile phones are already locked in and having no traffic. And as soon as the modem is asking for traffic or got traffic, the cellular network will decide to which base station the modem is the best to shift for business case, as well as for the speed which is available on the BTS. One thing which I have seen in the discussion already, please be careful to mix systems in a way where we have already interferences. So there's a well-known interference between 2.4 gigahertz high-speed connections like Wi-Fi or other free available links to the 4G LTE. They are overlapping on the band edges, and this can implement heavy interferences to a 4G use case scenario. And here again, we do not know which bands the operator will push to the terminal. This is related to the SIM and to his business scenario.
Wow, oh, great. Well, I can see there's quite a discussion about LEOs and Starlink in the answered tab, and there's another question coming from Andy Rose about autonomous vessels. I guess I don't know if maybe we'll stick with autonomous vessels and then maybe go on to LEOs and Starlink after that. Shall we? Is it anybody like to share any thoughts about how this fits in with the autonomous vessels?
Yeah, I can take that because directly in front of our door there's currently delivery of some new smaller ferries that go in the Kiel Fjord, full electric. The first one has now delivered, and there is a project in Kiel called Captain Kiel, which is looking also for autonomous vessels over about a distance of a maximum of 5 to 6 kilometers between the west and the east coast of the Kiel Fjord. But then Deutsche Telekom as well as Vodafone, two cellular operators, they are building 5G infrastructure on both sides to make this happen. And as we have seen in Frank's slide, there are 5G networks available which can cover about 3 to 4 kilometers. For autonomous ships, it is most important that you have redundant links. But of course, autonomous ships should also be intrinsically safe. That means they should be safe without a ship-to-shore connection also. But nevertheless, I think over the next 3 to 5 years, we will see good pilots also in the passenger ferry business or in commercial shipping that make use of such technology in a controlled coastal area, I would say.
Oh, I mean, autonomous cars don't need fast data bandwidth. I don't know what's intrinsic about the autonomous technology that you use.
Yes, that's what 5G is mainly used for in cities where you have distances between cars of a few meters or a few hundred meters, and you have overlapping cells, so that even if one cell goes down, another cell can take over without a safety risk. But we will not have that at sea over the foreseeable time, because the investment is huge for the operators, and they invest, unfortunately, there where the people are and where a lot of end users are, and this is not at sea. So that's unfortunately the situation.
Well, should we go on to this Starlink question on the answered tab? So there's a lot of discussion about LEOs, but I guess we talked about a whole whole chain of links with 5G together with satellite, and this is where the future is going to be. And these new satellites that aren't launched yet are promising enormous bandwidth, but it's all going to work together. Does anybody have any further thoughts they'd like to add to all this discussion? It's quite a lot to read there.
I think from the technical perspective, also as Dan wrote the question just a minute ago, there will be picocells, or however you want to call it, 5G on the ship in the near future, due to the fact that you want to have a coordination between, in example, container tracking and tracking the container over a long distance as well. So not only if the container is in a local 5G cell, which is land supported. In such a case, there is no latency problem to backhauling this over satellite because this is not a real-time communication. But in example, to control the sensor of an engine, or whatever case, maybe a real-time requirement is there. So, and if the 5G cell is developed and deployed on a ship, then this communication in the cell will be real-time. But it gets the same disadvantages if it gets backhauled by satellite. So we come from this very sportive 1 millisecond up to hundreds of milliseconds in some regions, and this is the limit. On the other hand, still we don't have a good regulation in place where we say how we avoid disturbances if such a picocell is going with a ship into a port which already may have 5G at the same frequency range. So therefore, there's a bit of development to do, but as the question is asked, I think 5G on board in some cases might be a good use case. In example, also for entertainment systems on yachts or on large passenger ships. So there is for sure a big advantage of 5G.
I mean, if we're talking about just the onboard communications, there's lots of alternatives like Wi-Fi and the automation networks like HART, or even just using cables. I mean, is 5G automatically better than all of these, do you think? I mean, you don't necessarily need the latency on a ship, I wouldn't imagine, for the communications on board a ship, or the bandwidth. You just want reliability, I suppose. That's
Yeah, the beauty of the 5G will be that the throughput is very high and the latency is very low, and the coverage is compared to Wi-Fi quite nice. So we can say a picocell or a small cell will be able to serve 1 kilometer with a 1 gigabit, and this is a huge advantage. Not for everybody, but where it is useful. And at the end of the day, it is a communication device, so it needs to be coordinated with others. And this is the con of that, to say how I get this done with an example, an authority in a foreign country. So do I have to switch off or whatever? So there is not yet a real decision made, I think.
Well, what about going through steel? Is it good with steel?
As higher the frequency is, maybe not. Yeah.
Okay.
So this is the question: how you do the antennas into an installation. So we had in the former days we had a leakage line. Therefore, you have in a tunnel, where if you drive by car through a tunnel, connectivity to the 4G system. But this could be just one thing. I think a solution would be having microwave over fiber. This is the like you do it in the towers. This might be the future for that, and that you also get the 1 gigabit deployed in cabins where you have metal walls in between.
Well, we had a question about IMO. Does someone see IMO catch up to implement 5G, or will it take another 10 to 25 years? This is on the answered page now, but I don't know if IMO needs to regulate this, do they? Or is there any benefit from IMO regulating something like this, or companies can choose what they want to use, do you think?
No, I think it's the same with every cellular network. It's regulated by the 3GPP and by the GSMA standard committees globally and by the ITU. So there are standard committees that are just covering more than IMO. And I think there will be no need for IMO to cover this topic directly. However, security, for example, that sits on top of such an infrastructure. This is for sure a topic that needs to be also looked at and is looked at by the IMO.
Oh, well, it looks like the open questions page is open, but it's empty. I've got one of my own talking about the carbon issue. So this is obviously a big issue with the IMO and the whole shipping industry in generally, and in Germany in generally. We're a lot of talk about collecting data. Do you have any thoughts about how this connects to having better bandwidth, if we're going to monitor what the ships are doing and how efficiently they're behaving? Do you see? Because we can get a lot of interest from people who care about the carbon if we've got a good story to tell about this. Do you think? Anybody have any?
Course, the more the better monitoring you can do, the better optimizing of the ship you can do. It will be beneficial to your carbon footprint that you produce. That's clear. And a 5G cell today already is able to connect to thousands of sensors. So this is also something that is an advantage to Wi-Fi, where we have limited number of end user devices that we can connect to. But on a 5G network, we can connect thousands of devices too. So if we need thousands of sensors on board a big cruise ship or on board a big container ship, we can do this with a 5G cell as long as we can connect it to a core network on shore.
Wow, and some comments here from Michael Bergman. He's asking about including GMDSS with 5G and GMDSS. I don't know if there's any.
No, that 5G is, as Frank and Dennis have both, I think, explained, is a thing that is very near shore. And I don't think that is even together with satellite, it will not be part of GMDSS.
Oh, yeah. I mean, the one theme that comes to me, kind of wrapping up now in the last minute, is sort of a lot of imagination and ideas this generates, because there's a lot of possibility, isn't it? And we think we can see a sort of pathway to the future with a lot more communications, and I guess that's the kind of most exciting thing, really, isn't it? Really, I don't know if maybe we'll go around and if everybody has a couple of minutes, sort of summing up talk about where you think, what issues do you think the industry should care about most? Because a lot of people reading this will be operating all kinds of ships up the African west coast, and they're not necessarily within 4G coverage, but there's still stuff they can take in. Maybe if we go to Holger and then Frank and then Dennis, about what's the main takeaways for shipping industry operators around the world, do you think, for this, for maybe 2 minutes each?
Yes, thank you. My biggest takeaway would be use cellular where it is possible today. It has already a lot of advantages. It's available from our perspective, more than 90% of the coastal countries. Even on 3G for commercial ship, you still have good bandwidth on 3G. 4G is, of course, provides you higher benefits. And important is that you have good roaming conditions and that you have equipment like the Sputnik that supports global standards. So the SIM card is important, good roaming SIM card, and equipment with global standards.
Well, Frank, do you want to give some takeaways to the audience, how this is relevant for shipping operators with all different kinds of vessels?
Yeah, from my technical perspective is, as Holger already explained, it is very important to choose the right service for the right country or the right or the shipping route, and also to collect the experiences in a way to having knowledge management about, in example, where are the problematic fields in the coverage, and where you are going very well. And 3G and 4G is in the moment, I think, state of the art for being a little bit longer reach, really to say it, you go a few kilometers out. And at the end of the day, kind of responsibility to the ship owner or to the IT or designer is how I can install an antenna like ours in a way that it has a good coverage, less blockage, to avoid also local interferences. And with doing that, then at the end of the day, you are on the hand at the sea of the operator of the 4G system, how far he let you go. So within a standard. Yeah. And I think that the 4G is at the moment a good solution if you have the fallback to 3G, that in several countries just 3G is available right now.
Yeah, and Dennis, I wrote down a quote from you. So you had a new build in 2008 with 2 network connections and one in 2018 with 100 network connections. And I think we can see where this trend is going. Reasonable bet your ship in 2028 will have 1,000 network connections. So I guess people need stuff like this to cope with what's about to happen. Is that fair perspective?
It's definitely like that, because more and more will be connected. What I just wanted to add is our main point is always, you know, the talks with the providers to get the right tariff options to really able to transfer this amount of data through normal SIM cards, and there we are still far behind. Because it's all on the part, if you get a contract, if you pay a high amount or whatever, that's still, especially also now with 5G, it will increase and we need more data, and then officially also the tariff options that we can really use that data there over. No? It's because it's all a matter of cost at the end as well.
Well, that's great. Well, I hope everybody knows more about 5G than you did an hour ago and are clear about the kind of direction and more questions to answer. So I'll pass back to Vida for the closing words. Thank you.
I'm grateful to our speakers, Holger, Frank, Dennis, for sharing their thoughts about 5G application in maritime. Also, we are grateful for DRYNET and Sputnik24 for joint sponsorship for the webinar. If you have a story, doesn't matter if you're a shipping company or technology company, we'd like to hear what new developments you have. So reach out to us directly anytime. And this Thursday, I'm inviting you to tune in again, 10 a.m. UK time this time, and we will talk about real-life solutions for remote maritime operations with Michael Owen from Marlin. Now, Digital Ship is signing off. Take care. Bye. See you on Thursday.
Cheers. Bye-bye.